Hi everyone, and welcome to the second video in the series on fractions. Recall in the first video we talked initially about number sets. First of all, the naturals, which is 1, 2, 3, 4, and so on. Then the integers, which includes 0, and which extends in both directions, plus minus 1, plus minus 2, plus minus 3, and so on. And then finally the rationals, which we enumerated as P over Q, where Q was an element of the naturals and P was an element of the integers. Now, we want to concentrate once more on that third set, the rationals, because this is where our fractions were generated from, using the representation of P on Q. So let's have a look at some examples of the rationals. 1 over 2, 2 over 4, 3 over 6, 5 over 8, 6 over 10, and 5 over 4. All of these are examples of rational representations or fractions. So let's have a look at what these fractions mean. 1/2 means 1 part present out of a total of 2 parts. 2/4 means 2 parts present out of a possible total of 4 parts. And 3/6 means 3 parts present out of a possible total of 6 parts. Looking at the remaining fractions, 5/8, 5 over 8, we have 5 parts present out of a total of 8 parts. Next one, 6 over 10, we have 6 parts present out of a total division of 10 parts. And interestingly, the last one, 5 over 4, which is an improper fraction, we have 5 parts present out of a division of 4, which means this is a fraction that lies not between 0 and 1, it's greater than 1. So it lies between the two counting numbers 1 and 2. So it's 1 plus 1/4, which you can see from looking at that complete circle plus 1/4 of a circle. So this is an improper fraction which can be rearranged to be what is known as a mixed number, a whole number and a fractional part. Addition and subtraction of fractions. A common denominator. What's a common denominator? Well, it means no matter what we have up top in the way of the numerators, the denominators for both or for all three, or however many fractions we have, stays the same. Before we can write our 2 or 3 or 4 or however many fractions we're adding over one common denominator, we need to convert them all individually so that they have a common denominator, as we can see here in this case with 2 fractions which share a common denominator. 1/2 plus 3/5. 1/2 is 1 over 2. The denominator is 2. 3/5 is 3 over 5. The denominator is 5. So we now have to find a common multiple for 2 and for 5. Well, let's start by superimposing one on top of the other so we can see whether we have less than or more than one whole. If I make the red 1/2 transparent and rotate it round to cover the white portion of the 3/5, then we'll see that it also covers some of the blue, as indicated by the 3 blue dots. The question is, how much of the blue does it cover? What is that additional fraction? So we have one whole plus this additional part. How can we work that out? Returning to the earlier example of 1/2 plus 3/5, we'll now use blocks. So if we slide these over so that they're above and below each other, we're now going to expand on them to see at what point we can make them align. If we add multiples of the numbers of blue blocks, so 2, 4, 6, 8, 10, and if we add multiples of numbers of red blocks, so 5 and 10, we find that 2 groups of the 5 red blocks and 5 groups of the 2 blue blocks give us a common multiple. This is the basis for how we find a common denominator. Common multiples and the lowest common multiple, LCM, of a group of numbers. Recall, a multiple of a counting number is the result we get when we multiply that counting number by an integer or typically by another counting number. For example, multiples of 2 are 2 times 1 is 2, 2 times 2, 4, 2 times 3, 6, 2 times 4, 8, and so on, giving 2, 4, 6, 8, 10. Multiples of 7. 7 times 1 is 7, 7 2s are 14, 7 3s are 21, 7 4s are 28, and so on. Multiples of 11. 11 1s, 11, 11 2s, 22, 11 3s, 33, and so on. These are how we list multiples of a number. Example, find the common multiples of 6 and 9. Well, the multiples of 6 are 6, 12, 18, etc. The multiples of 9 are 9, 18, 27, etc. Now, the first common multiple is 18. The next common multiple that appears in both sets is 36. Then the next after that, as we can see, is 54. So one thing to notice is that the common multiples are actually multiples of 18, which is the lowest common multiple of 6 and 9. Example, find the common multiples of 5 and 10. Multiples of 5 are 5, 10, 15, 20, etc. Multiples of 10 are 10, 20, 30, 40, 50, etc. But notice that every multiple of 10 is already a multiple of 5. Therefore, the common multiples are every multiple of 10. 10, 20, 30, 40, 50. That's because 5 divides into 10. Example, find the common multiples of 2, 3, and 6. Well, 2 is 2, 4, 6, 8, etc. Multiples of 3 are 3, 6, 9, 12, etc. Multiples of 6 are 6, 12, 18, etc. Notice how I've lined them up so that we can immediately see the common multiples. 6, 12, 18. And we can do this for however many groups of numbers that we want, not just 2 or 3, but maybe the common multiples of 10 numbers if we wanted. 1/2 plus 3/5. Now visually, let's look at multiples of this denominator, 2. So we have 2, 4, 6, 8, 10. And we list them here above the blocks. And let's do the same for the denominator of the right-hand side fraction, which is 5. Multiples of 5 are 5 and 10. So at the point of 10, we have a common multiple for 5 and 2. 1/2 plus 3/5 is equal to something over 10 plus something else over 10. So how do we scale these two fractions up to have a denominator of 10? Well, we look at the denominator here. 2 was scaled up to 10 by a multiple of 5. So to keep the fraction proportional, we scale the numerator up by a multiple of 5, 5/10. Do the same to the fraction on the right-hand side. The denominator was scaled up by a multiple of 2. So we do the same to the numerator, and we have the new proportional fraction, 6 over 10. 5 over 10 plus 6 over 10. We have a common denominator, 5 plus 6 over 10, which gives us 11 over 10, because once we have a common denominator, we simply add the numerators. Now, looking at 11 over 10, we can express that as 1 whole plus 1 over 10. So 11 over 10 is an improper fraction. That's where the numerator is greater than the denominator. And if we have a numerator greater than the denominator, then we can express that fraction as a whole number, in this case 1, plus the remaining part of the remaining fractional part, in this case 1 over 10. So 1 and 1/10. Examples. Number 1, 1/2 plus 1/3. Number 2, 5/6 plus 5/8. Number 3, 4/3 plus 1/4. Number 4, 7 over 2 minus 9 over 4. So let's start with number 1. 1/2 plus 1/3. Well, let's look at the multiples of the denominators. Multiples of 2 are 2, 4, 6. Multiples of 3 are 3, 6, 9. So 6 is the first common multiple. So we scale 2 up to 6 and we scale 3 up to 6. So for the left-hand fraction, if we scale 2 up to 6, we multiply by 3. So we multiply the numerator by 3. 3 ones are 3. For the right-hand fraction, we scale the numerator up by 2 because we've multiplied the denominator by 2. So we get 2 over 6, giving an answer as we add the numerators of 5 over 6. 5 over 6 plus 5 over 8. Well, the multiples of 6 are 6, 12, 18, 24, etc. Multiples of 8 are 8, 16, 24, etc. So 24 is the lowest common multiple. So now we have two fractions with a denominator of 24. To scale 6 up to 24, we multiply by 4. And to scale 8 up to 24, we multiply by 3. So looking at the numerator of the left-hand side fraction, multiplying the numerator by 4, we get 20. And looking at the numerator of the right-hand side fraction, scaling up by 3, we get 15. The answer is 20 plus 15, 35 on 24, which can also be written as 1 whole plus 11 on 24, since this is an improper fraction. 4 over 3 plus 1 over 4. Well, let's look at the multiples of the denominators. Multiples of 3 are 3, 6, 9, 12, etc. Multiples of 4 are 4, 8, 12, etc. So 12 is the lowest common multiple. So we have something over 12 plus something over 12. Scaling 3 up to 12 is multiplying it by 4, and scaling 4 up to 12 is multiplying it by 3. So the numerator of the left-hand side fraction is multiplied by 4, giving 16. And the numerator of the right-hand side fraction is multiplied by 3, making it 3. So adding the numerators, 16 plus 3, 19 over 12, which can also be written as 1 whole plus 7 over 12. So 7 over 2 minus 9 over 4. Well, this time it's minus, but that's exactly the same as if it were plus. So 2 is a factor of 4, and 4 is a multiple of 2. So 4 will be our common denominator. Something over 4 minus something else over 4. So scaling 2 up to 4, we multiply it by 2. And scaling 4 to 4, we multiply it by 1. So 7 multiplied by 2 gives 14. And 9 multiplied by 1 gives, of course, 9. So 9 over 4 stays as 9 over 4. And 14 minus 9 is 5 over 4, which can be written as 1 whole and 1/4. Hopefully that gives a clear idea of what it means to add and subtract with fractions. So we'll leave it at this, and in the next video I'll be moving on to multiplication and division of fractions, which is in some regards easier than addition and subtraction. Thanks guys, and if this was helpful, feel free to like and subscribe, and I'll be trying to regularly create more content over the coming months.